Let's calculate amplitude and phase for harmonic field. In this case, the fields that we are going to calculate amplitude and phase will be current density, which consists of imaginary and real part, and each of those parts consists of vectorial values. So first, we will calculate the amplitude for this field. Choose all windings in results in ParaView, and then click on the calculator icon here on the left corner. Next, in the calculator filter, write the name for your array that you're going to create. And to calculate the amplitude, you can write square root of the dot product between current density real part, plus dot, and for imaginary part, dot product. After that, the software will calculate the amplitude for both real and imaginary parts and for all of vector components. So for example, in this case, you can see that the current density in all of those bus bars is the same. It looks roughly the same. But if we, for example, would look on the current density imaginary part, you would see that on one side it has higher amplitude than on the other side, and the same picture is with a real part. So because those are phase shifted in time, therefore we see real or imaginary parts are larger. But once we calculate the amplitude, then we see that that all currents are pretty much the same. So the next part is to calculate phases for the currents. And here we need to be careful, because for each of vectorial components, vectorial fields, we would need to calculate a separate phase. If we don't do so, then we will see likely we will see the x phase for the x if we don't define coordinate the direction. So the functions that we are going to use is atom2, and in this atom2 we have to specify the imaginary part and real part. So once I set up this for x, I will see the phase in x direction. If I would change to y, then I would see the phase in y direction, which in this case would be vertical. And if I would set, sorry, not vertical, but horizontal. And if I would set z, then I would get the vertical. So let's take a look. For example, if I set z here and here, then we would see that the phase is calculated in those vertical parts of the bus bar. And because there is very small current flowing in vertically in, for example, in this part or in this part of the bus bar, the results of the phase are very grainy, because those current densities are just too small to accurately calculate the phase in a given point. Also, one more thing. So let's go back to the x. Be careful when you are reading those values, phase values, because even in such case like this one, you may, for example, by using so you will see that here on the right side is the maximum and minimum amplitude, which is like plus pi and minus pi. But the actual values on the bus bar will be likely different. For example, on this wall, we would get 2.69 radians of phase. But if we switch here to the center, we would get 0.57. So those values for the phase, they can vary very, very strongly. So therefore, when you will estimate phases, of course, you would expect to phases be 120 degrees between each of those bus bars, but it's very important you to read those values in the right points.